Hi, we are going to talk about something called average rate of change. Let's start with a simple situation. So you're taking a trip that's 200-mile long, you completed that in 4 hours. What is the average speed? This is kind of like problems that you've seen before for probably a number of years now. So we simply take 200 divided by 4 and get 50 miles per hour. That's our average speed on this trip. But what does this actually represent? If you look at that a little deeper. So 200 mile represents the change in position. You left one place, you ended up in another place 200 miles away. 4 hours represents the change in time. You left one place and then 4 hours later you were in another place. So the answer tells you that on average the position was changing with respect to time at 50 miles per hour. So if we assume that the initial time was 0, t equals 0, and the initial position was p of 0 was also 0, then we can rewrite that in the following form, and it's going to look like this. P of 4 minus p of 0 divided by 4 minus 0, so 200 minus 0 over 4 minus 0, and that's going to give us 50 miles per hour. Then the question is going to be, why do I have to go through all that if this seems a lot easier? And I do agree with that. However, let's consider this. So a car is moving on a straight road. The position of the car is 120 miles at t equals 2. The position of the car at t equals 6 hours is 320 miles per hour. Find the average speed. So now the same approach that we just talked about, the one that we started with, is not going to work. So we need to do it actually the other way that I just showed you. So what we're going to do is we're going to do the position at 6 minus the position at 2 divided by 6 minus 2. This is actually called the difference quotient. Okay, because you have difference on top and difference on the bottom. And now we'll do 320 minus 120 over 6 minus 2. That's going to give us 50 miles per hour. So it's actually the same answer as in the previous problem. We just modified that with some different values that we have. So what is it? This is the average rate of change of the position on the interval from 2 to 6. So to find the average rate of change of any function on some interval from a to b, we are going to use the following formula. The average rate of change of f of x on the interval from a to b is going to be f of b minus f of a divided by b minus a. Okay? So let's take a look at some problems, and this is actually a very simple process, but I do have one thing that I want to show you that is going to show you some geometric interpretation of this. So let's start with this. So we're given this graph. There is an equation associated with that graph too, but we are actually going to use the graph. So we want to find the average rate of change on the interval from 1 to 4. So at 1, the value here is -4. So this is x, this is f of x. And the other point is 4, so it was 4 comma 5. Okay? 4, 5. So, if we are actually going to follow this, and again, this is x, this is f of x. So let's say this is my a, so this will be my f of a. This is b, this is going to be my f of b. And all I need to do now is write that, so it's going to be 5 minus -4 divided by 4 minus 1. Correct? 5 minus -4 divided by 4 minus 1. That is 9 divided by 3, which is 3. So the average rate of change for that function on that interval is 3. But what I want to point out to you here, what does that number actually represent? Here's a point 1, -4. Here's a point 4, 5. If I draw a line through those 2 points, I missed a little bit, but the slope of that line will actually be, the slope of that line will actually be 3. So the geometric interpretation of this answer, it is the slope of the secant line that passes through those 2 points. I want to remind you, secant line is a line that goes through 2 points on the curve. Okay? But most of the time these problems are going to be given to you in the form of just a function and an interval, and you just do it. So example 3, find the average rate of change of this function h of x, right there on this interval. So here's what we do. We set it up so it's f of 2 minus f of negative 1 divided by 2 minus 1, negative 1. So f of 2, that's going to be 2 squared minus 3 times 2 plus 5 minus f of negative 1 is going to be negative 1 squared minus 3 times negative 1 plus 5 all over 2 minus negative 1. I know I can calculate that, but I'll just wait until all the other stuff is done. So this is 4 minus 6 plus 5 minus, this is 1 plus 3 plus 5 all over, let's change it to 2 plus 1. So 4 minus 6 plus 5, that is going to give us 3 minus, here we have 9 over 3. That's going to be negative 6 over 3, which is negative 2. That's the average rate of change of that function on that interval. Example 4, the function, the interval. So the average rate will be f, no, yeah, f, I should have used h here, my apologies. F of 11 minus f of 3 divided by 11 minus 3. So f of 11 is going to be the square root of 11 minus 2. F of 3 will be the square root of 3 minus 2 all over 11 minus 3. That's square root of 9, that's 3. That is square root of 1, which is 1, divided by 8. So it's 2 over 8. Or we can simplify it to 1/4. Alright. Couple more. Find the average rate of change of that function on the interval from 1 to 2. So it's going to be g of 2 minus g of 1 divided by 2 minus 1. G of 2 is going to be 1/4. G of 1 is going to be 1 divided by 1. So 1/4 minus 1 is going to give you negative 3/4 divided by 1 will be negative 3/4. Okay, you can use it with absolutely any continuous function. The function must be continuous on the interval, so we can do it even with the trig function. So what do we have here? We got to do sine of pi over 4 minus sine of 0 divided by pi over 4 minus 0. Sine of pi over 4 is square root of 2 over 2. Sine of 0 obviously is 0 divided by pi over 4. So we have square root of 2 over 2 divided by pi over 4. We don't like complex fractions like this, so we can simplify that. It is actually going to end up being 4 square root of 2 over 2 pi. Traditionally, we don't like having irrational values on the bottom of a fraction, but in this case, it's not going to be an easy thing to rationalize it, so we're just going to leave it like that. That's still a valid answer. Alright, hope this helps.